Open your book to page 298. Today's lesson is on vectors. Vector is something that has length and direction. The length is also called a magnitude. And example of the vector would be like this. Okay. So this is the example of a vector. Now this is a head, and the way to remember is that the head shows you which direction the vector is heading. So the heading would be the head, and this over here is the foot. Okay. And normally you use a capital letter to name a vector. So like this is the vector A. Now if you go in opposite direction, then they are not the same. So in order to be the same vector or the equivalent vector, you have to be in the same length and same direction. So this would be like negative A, because it's going opposite direction. Now the vector can slide over. So for example, if A over here, you can slide it over here, you can slide it anywhere, as long as it's heading the same direction and have the same length. Okay, so in other words, if this is your vector A, you can slide it over here. You can slide it anywhere. Okay, as long as the heading is the same, as long as you don't change the heading. Okay. Now let's go over page 302. Page 302, and there are some multiplications and also addings. So if this is A, and if you multiply by 2, this would be 2A, right? Twice as long. So that's what that is. And if you go this way, this would be 1/2 A. Okay. So there's some example of that. Now you also can use the coordinate form, the component form. And let's say if you have this vector over here. So this vector, let's call it vector A. Now you use a boldface type to indicate the vector, or sometimes very hard to see with a pen or pencil. So sometimes you want to put a little arrow up here to indicate it's a vector A. Okay. In the book they just use a bold type letter. Okay. So for us, we probably want to put a little arrow on the top to indicate it's a vector. Now in this case, you can use a component. So this is the x direction, right? So in the x direction, each of these would be using the I, and the y direction use the j. So in this case, to go from here to here, if we break in the component form, it's same as going 4, 3. So this is equal to 4i plus 3j. So I and j's are unit vectors, means one unit in those directions. So 4i plus 3j. So 4i plus 3j. So you can write this in a component form. And the purpose of writing this in component form so that it's easier to work with. Now on page 304, the page 304, it has something called a unit vector. Unit vector is the vector with length of 1 and have the same direction. Let's say if this is your A, so let's say you have an A vector, it's equal to 4i plus 3j. And if you're looking for the unit vector, we're going to call it U. So unit vector, you want to find a unit vector of that. So basically what you want to do, you're looking for the vector have the same direction but have the length of 1. Okay, so you're looking for this vector right over here. Okay, the way to find the unit vector is you just use a vector divided by its length. Okay, because right now this length is 5, right? Use Pythagorean theorem to find the length. So in other words, over here, the absolute value means length, right? So the magnitude or the length or absolute value of A is equal to square root of 4 squared, right? A squared plus b squared, and so this will equal to 5. So the length equal to 5. So to find a unit vector of that, since this is 5, and unit vector is length of 1, right? So this is length of 5. Unit vector means length of 1. So if you divide this by 5, then you get a length of 1, right? So unit vector basically means just divide this by its length. So you're going to get 4i plus 3j divided by its length, which is the 5, right? And so unit vector would be 4 over 5i plus 3 over 5j. So this will give you the length of 1. If you use a squared plus b squared, it will give you equal to 1. So again, unit vector is a vector has length of 1 and is the same direction as your original vector.